This is the problem given on Sumpner's test. Here the Sumpner's test is carried out on two similar 250/500 volts 6 kVA transformer, and it is observed that a 250 volts is applied and the wattmeter reading was 160 watts and the ammeter reading was 3 amperes. Similarly, on the other side, the voltage applied is 40 volts and the wattmeter reading was 200 watts and the ammeter reading is 12 amperes. And he is asking you to determine the equivalent circuit with respect to LV side. Also, we need to determine the efficiency of the transformer operating at 80% of full load and a power factor of 0.75 lagging. Let us write what is the data given. This is as per our representation. This is voltage across LV, this is WLV, and this is ILV. Similarly, this is voltage VSC, this is WSC, and this is ISC. Let me write all the given data. The voltage applied across the primary is 250 volts and the current flowing on the LV side is equal to 3 amperes and the wattmeter reading on LV side is 160 watts. Now we will convert these values into open circuit test and the short circuit test. As this is in parallel, VLV is equal to VOC and that is equal to 250 volts. As the current will get divided, ILV is equal to 2 times the IOC. Hence the current IOC is equal to 3 by 2, that is equal to 1.5 amperes. As the wattmeter reads the iron losses in both the transformer, hence WOC is equal to wattmeter reading on primary LV side divided by 2, that is 160 by 2, that is equal to 80 watts. These are the data extracted from LV side. Similar data we need to extract from the HV side also. The voltage on HV side is equal to applied voltage is 40 volts and current flowing through us HV side is 12 amperes and the wattmeter placed on HV side will reach 200 watts. They are in series, hence this voltage will get divided. That is, the voltage on HV side is equal to 2 times the voltage on SC side, where VSC is voltage across each winding on secondary side. Hence VSC is equal to VHV divided by 2, that is 40 by 2, that is equal to 20 volts. Similarly, IHV, as they are in series, the current is same. IHV is equal to ISC. This wattmeter reads the total copper losses in both the machine. Hence, WSC is equal to WHV divided by 2, that is equal to 200 by 2, that is equal to 100 watts. Now we are going to use this one, WOC, VSC, IHV, that is ISC, and WSC in our calculation part. The same formulas what we used during the OC and SC test will be used. We know that the WOC is equal to VOC into IOC into cos 5 OC. From this equation, get the value of cos 5 OC. WOC we know the value is 80 divided by VOC is 250 and current IOC is 1.5 amperes. Substituting that and simplifying, we will get cos 5 OC as 0.21. Similarly, get the value of sin 5 OC. Now get the value of IW, and we know that IW is equal to IOC into cos 5 OC. IOC is 1.5 and cos 5 OC is 0.21. Hence, IW is equal to 0.32 amperes. Get the value of magnetizing current. I magnetizing is equal to IOC into sine 5 OC, that is equal to 1.5 into 0.977, that is equal to 1.466 amperes. Now get the value of R0 and X0. Remember, these values are with respect to LV side. Hence, let me write this as R0 on LV side is equal to VOC divided by IW, that is equal to 250 divided by 0.32, that is equal to 781 ohms. Now let me calculate the value of X0. This X0 is also with respect to LV side. X0 is equal to VOC divided by I magnetizing. VOC is 250 and the magnetizing current is 1.466, and this is equal to 170.5 ohms. And from SC test we know that WSC is equal to ISC square into RE. This is with respect to HV side. Hence, the equivalent resistance referred to HV side is equal to WSC divided by ISC square, where WSC is 100 and ISC is 12 square. Hence, this value is equal to 0.6944 ohms. The equivalent resistance referred to LV side. Hence, let me convert this into LV side, and it is given by K square, where K is transformation ratio. K is equal to I1 by I2, and that is also equivalent to E2 by E1. And we know the values of E2 by E1 as 500 by 250. Substituting this here, 0.6944 divided by K square is 500 by 250 whole square. Substituting the values, simplifying, we will get this as 0.1736 ohms. Now this is the equivalent resistance with respect to LV side. Now get equivalent impedance with respect to HV side, that is equal to VSC divided by ISC, and we know the value of VSC and ISC as 20 by 12. Hence, that is equal to 1.667 ohms. Now we will shift this impedance to LV side, that is ZE of LV is equal to ZE of HV divided by K square, that is equal to 1.6667 divided by transformation ratio is 500 by 250 whole square. After simplifying, we will get this value as 0.41675 ohms. We know the equivalent resistance referred to LV side as 0.1736 ohms and equivalent impedance referred to LV side as 0.41675 ohms. Now get the value of XC of LV, that is XC of LV is equal to square root of 0.41675 whole square minus 0.1736 square. Simplifying this, we will get the equivalent impedance referred to LV side as 0.3788 ohms. Substitute all the values in the equivalent circuit. This is 250 volts and R0 is 781 ohms and X0 is 170.5 ohms. The equivalent resistance referred to LV side is 0.1736 and the equivalent reactance referred to LV side is 0.3788. Similarly, we need to get the value of the first part is over. Getting the equivalent circuit is over. To determine the efficiency of transformer, the general formula for determining the efficiency of the transformer, efficiency is equal to X, where X represents the load X and output in kW divided by output is X in kW plus the iron losses plus X square times the copper loss. Let us substitute all the values here. Is asking us to determine the efficiency at 80% of full load and the power factor of 0.75 lagging. X is 0.8 and output is, and the output in kWA is, that is kVA rating of a transformer into power factor. The power factor is 0.75. The iron losses are obtained on the primary side, that is equal to 80 watts, and the X square, that is the load he has given is 80%, hence let me get it is 0.8 square, and the copper loss is 100 watts. So after into 100, after simplification, we'll get the answer as 96.15%.